Hello everyone, I'm Lina, Network Solution Engineer at ALE. In this session, we will focus on integrating Entra ID, formerly known as Azure AD, with our ALE network management solution OmniVista, to enable secure wired and Wi-Fi authentication. After a brief introduction to the key concept, we will move on to a hands-on demonstration of the deployment, showcasing how Entra ID and OmniVista work together to provide secure and centralized network access management. Stay focused and let's dive in.
Let's move on the network integration part. Before we dive into the integration, let's take a quick look at Entra ID, formerly known as Azure AD. It's a cloud-based identity and access management solution. It provides authentication and authorization services for hybrid and multi-cloud environment. This solution helps centralize and secure user authentication while guaranteeing access to specific network resources, making it a powerful tool for managing enterprise security. Now, why should we integrate Entra ID with OmniVista? There are three main reasons. Enhanced security. Our system leverages advanced encryption standards, a zero-trust architecture, and continuous monitoring to significantly boost network security. Centralization and efficiency. This integration minimizes administrative overhead by centralizing the management of all authentication processes. And fully cloud-based. By adopting this approach, organizations can simplify their IT infrastructure, eliminate on-premises authentication servers, and enjoy a seamless transition to a cloud-based environment. Let's walk through how user authentication works in this setup. The process begins when a user connects either to OmniSwitch for wired access or to a stellar access point for wireless connectivity. The user then initiates authentication using EAP TTLS, which securely tunnels the credentials to the switch or access point. Next, the OmniSwitch or API or access point forwards the authentication request to UPAM. OmniVista built-in Radius server using the Radius protocol. So, UPAM then communicates with Azure Entra ID through Azure REST API over HTTPS. Entra ID handles the validation of the user's credentials and retrieves their identity. Finally, based on the verified identity, UPAM assigns an access role profile to the user. This profile defines the user network access permissions. Once applied, the user is guaranteed access to the network according to the assigned policy. Before you begin the configuration, you need to ensure that you have the necessary component in place, an OmniVista and Entra ID subscription, and compatible access points and switches that support this integration. Once these requirements are met, you can proceed with the setup. In this demonstration, we will walk through the configuration of Entra ID and retrieve the necessary parameters to create a cloud identity within UPAM on OmniVista. We will then verify the REST API connectivity using Postman and proceed to configure both wired and wireless authentication using the cloud identity. And finally, we ran a complete test to validate the entire setup. To get started with Entra ID, log in into your Entra ID account. From the home page, select the Microsoft Entra ID, then go to the app registration and choose your organization. In the left-hand menu, click to the Certificate and Secret. Then select Client Secret and generate a new client secret. And make sure to immediately copy the value as it won't be visible again. We recommend saving it in an Excel sheet or any secure place of your choice. As I do, I prepared an Excel sheet. And here I save my secret value. Next, go to the Overview section and copy the client ID and tenant ID. Now, if you return to the main menu of your Entra ID, go to the Custom Domain Names to retrieve your domain name and save it as well. At this point, you should have all the values needed to create your cloud identity on OmniVista. But before moving on, we need to enable the required API permissions. You go to the API registration again and you choose your organization in the API permission. We can add it. In Add Permission, in Microsoft Graph, we have two choices: the delegated permissions and application permissions. So in delegated permissions, we have to enable the OpenID offline access profile, and user read is already on. And in application permissions, we have directory read all, group read all, group read and write all, identity provider read all, and user read basic all. And we will make sure they are all guaranteed. And now, in the endpoint, in Overview section, in Endpoint, we should to copy the appropriate endpoint URL in Authentication 2.0 token endpoint v2. And go to the Postman. So, use this URL to test the REST API in Postman. Now in Postman, enter the necessary information to perform the test. Your client ID, your client secret, and as a grant type, you put your password or password of one of users on your organization. In scope, you put all the delegated API permission, user read, OpenID, profile, and offline access. And username and password is one of your users in your organization and his password. See all users of your organization, you can just see it in all users, and here you have all your users. And when you do send, If you get the expected response, congratulations, the first setup is complete. Now let's switch to your OmniVista account where you manage your network. We are going to create the cloud identity that will be used for authentication both wired and wireless clients. To do that, go on the left-hand menu. In the Network Access, UPM-NAC and External Resources, you choose the cloud identity and here you can create a new one. Here is simple. Enter the value you retrieved in the previous setup and that's it. One of the easiest setup completed successfully. Let's dive to the wired configuration. In this step, we are going to configure a wired network still within your OmniVista account. We'll start by creating an AA server profile, which defines the authentication and accounting servers used for client verification. In Unified Access, choose the AAA server profile, and here you can create a new one. Give the profile a name, either your organization's name or any custom label. And for both authentication and accounting servers, simply select UPM Radius server. And just like that, your AAA profile is ready. Next, we will create an access authentication profile. Select Create Access Authentication Profile. Start by entering a profile name. And then you can choose a default access role. An example, Acme Restricted. The access role which determines the user's permission and access level on the network. If you haven't created one yet, you can do so easily by checking the blue button here. Launch Create Access Role Profile page in a new browser tab. You do next. In this setup, assign the profile to a specific device and define the port users can connect to. And just like that, we have created access authentication profile. Now we need to create an access policy, which brings all the components together to control how users authenticate. In UPM-NAC, access to access policy, and here we can create an access policy. I have created before. So in these steps, in the mapping condition, you choose the network type and operator equals and value is wired. And here we choose cloud identity as your authentication strategy and select the identity we created in the previous step. And that's it. The wired connection is now fully configured. We will test it right after setting up the wireless connection. So, still in our OmniVista account, go to the wireless section, then select SSID and click on the blue Create SSID button. Start by entering a profile name. The SSID name will automatically match the profile name, but you can change it if you prefer. For usage, we will configure it as an enterprise network for employee. When selected this option, an access policy will be automatically created. For authentication source, we choose our cloud identity we created before. And configure automatically or choosing an access role attribute. In second setup, you add your seat to filter groups. In the second setup, choose your access point group. And finally, select the VLAN to associate with the SSID. And that's it. Your wireless SSID is now ready to be deployed. So now, let's test both the wired and wireless connection. Starting with the wired connection, plug your Ethernet cable into the port you previously configured and connect it to your PC. In Network and Internet setting, select Ethernet and enter the user credentials that should already exist in your Entra ID under the user section. Once that's done, the connection should be successfully established. And we can test that just to tap the URL of Google. This works. And now you can monitor and verify this connection through the logs either in OmniVista or directly in Entra ID, and we can check the ports in our switch. The first in OmniVista. At the network access record, authentication record, we can see we are connected with a device type, employee, and username we used for connection EMP. And here we can see an additional details as authentication method EAP-TTLS or authentication resources cloud identity and network type wired. And now we can check this in our Entra ID, seeing in logs. Here we can see the user is EMP in application Acme is success, and you can see the additional information here. And if we check in our application, or our organization, in the users and groups, I can find my user EMP I have created before. If we enter the command show EMP users, we can see the port that we configured in our switch. In OmniVista, as we can see in network access, in unified access authentication profile, and my authentication profile is named Acme, and if I do next, I can see my devices, a segment for the port EMP, and I found the port 112. As well, you can see your port that you configured before. Next, let's do the same for wireless connection. Simply connect to the SSID you just created and again use the same user or different credentials from Entra ID. And now we are successfully connected. And we can check that on our logs in OmniVista. As before. And you can see here we are connected as EMP username and profile employee. And here we can see the additional information like network type wireless, authentication resources, cloud identity, and authentication method EAP-TTLS. And in our Entra ID we can check the logs too. And here we can see the EMP is connected to the Acme application. To conclude, let's summarize the key benefits of integrating Entra ID with OmniVista. Enhance security through modern authentication protocols and continuous monitoring. Centralized and efficient management by reducing administrative workload and streamlining user access control. A fully cloud-based approach that eliminates on-premises authentication servers and provides a scalable and flexible solution. By following these steps, organizations can enhance their network security while simplifying IT management.
That brings us to the end of this presentation. I hope this walkthrough has helped you understand how Entra ID and OmniVista work together to provide a secure and efficient authentication system. Additionally, there is a detailed application note that explicitly explains each step in detail. Thank you for watching and see you in the next session.